Hey guys, I'm Jim, KN4YCD, and you're watching FEP Labs Radio. Thanks for stopping by. Let's jump in and take a look at the micro SDX 8-band HF transceiver. This is a QRP transceiver that covers all the HF bands and 6 meters. Stick around.
Hey guys, we have a petite little radio to look at today. This is the micro SDX HF transceiver, and this is all mode 8-band. This radio comes in a very small form factor package. I don't know, this is probably about 4 inches long, inch high, probably 3 inches wide. Very small radio. I bought this used from a buddy of mine, Joseph, VE3GKT, and he had it and he's used it, and he didn't want it anymore, so I got the chance to buy it. These are available now on Amazon and all over the internet. So it's an all metal case, BNC connector on the back side. It comes with this tiny little microphone right here, and it has a PTT button on the side, and that's about all it's got. All right, very small clip on it, and this goes in the back of the microphone right here where it says KJ, which probably means Kenwood connector or something, I don't know. It also has a spot, as you can see, for a external mic and PTT out and CAT, and then the HP connector, which I believe is the amplifier. I would have to check that. And of course it runs on a standard 12 volt power supply, battery, whatever you have, and BNC connector. So I've got the power supply hooked up. Let's plug this guy in. So that's kind of what it sounds like, obviously, because I don't have anything plugged in for an antenna. This knob is somewhat of a multifunction knob. So right there it tunes for us. Let me zoom this camera in a little bit. Okay, so now you can see the display pretty well here. The knob is a multifunction knob, and we also have these two buttons down here on the bottom, menu and exit. The pushing the button changes our tuning increments when we're on a frequency, right? So we can tune by tens or hundreds of kilohertz or megahertz, obviously, right? Exit takes us out of that. And that also changes modes when you hit the exit button, right? USB, lower sideband, CW. All right, if we hit menu, then we can select volume. And we can turn that volume down so we don't have to listen to whoosh. You hit exit to back out of it. And then I can change modes through all this. So now we're back to the main screen, and then of course, obviously we can change it. So what I'm going to do now is I'm going to shut this thing off, and we're going to take the lid off and jump inside and take a look and see what it looks like. Okay, so we've got the cover off this guy, and we'll take a look at the inside. I'm not going to completely break this down. You can see here's all our connectors on this side. The board looks like it was put together very well. These are a lot of surface mount components on this board, on this side. The solder job looks really good and very clean. Here, of course, is our display attached by a ribbon cable, so I want to be a little careful with that. Here are, let's turn that right side up. Here is the board on the other side, and here are our toroids and relays for each of the bands this radio will do to switch bands out and then to tune each band. And you can see that the number of wraps, right, is different on each band. Some bands have more, some bands have less, and there's a couple of different mixes of toroids that are in use there. So this is really nice looking. Like I said, the construction on this is really good. This is a very nice, well put together board. I've got an antenna hooked up outside. The storm finally passed, and I didn't feel like I'd be electrified if I went outside. I'm on 40 meters right now on FT8 frequency. I have the volume turned all the way down, so I'm going to turn this up a little bit. And you can hear that we're doing just fine volume-wise on FT8. So let's punch out of that. And let's change our frequency up into the phone band on 40 meters. And there we go. Guess it would help if I changed to 40 meter phone. I should probably change the lower sideband. There we go. And so this is showing our background noise level. I think we can change this to bars. That's one of the settings in the menu. Let's see if we can find that. What was one of these settings? There we go, our S meter. So we can change that to S units or to dBm. So we'll change that to S units. And so that's showing our noise level as S4, which is what most of us are used to looking at for background noise level. So the antenna I'm on is the Cartenna Artemis. So this is an end-fed half wave. And this thing is tuned pretty solid for 40 meters. The one thing I will say would be nice is this radio does not have a waterfall, so you kind of got to drive around. Let's change bands and go somewhere else. Let's see, menu. Band, I saw it somewhere. There we go. So press, turn, let's jump down to 20 meters. Let's exit out of that. And now we're on 20 meters, so let's get out of the FT8 band. There we go. So that's a really good signal coming in right there. So we don't have a tuner on this.
Okay, it seems to be getting a little bit farther now. Thanks for calling in.
And it is 5:45 p.m. local time here in Central. So it's getting a little later in the day for 20 meters, but it's working. So the next thing I want to do is let's turn this guy off, and then we're going to hook up a meter and see what kind of power output we got on this guy.
4 Alpha Charlie Lima. Handle here is Manning, Mike Alpha Nancy Yankee, and I'm in Florida, southern Florida, just north of Miami. How do you copy? Now I'm confused. Is it Whiskey Charlie Lima. Roger, roger.
Okay, so I've got it hooked up to the spectrum analyzer right now, and this is that little radio we're talking about, and he is running out to my dummy load / RF tap, and then from the RF tap side of the dummy load into the Regal spectrum analyzer. And I've got the radio set for CW mode because it's the easiest to see a signal, and I'm kind of looking for two things here. I want to see what this is showing the signal looks like. CW will show up very clean. It doesn't use sideband, so it's easy to see if there's any spurious signals, any harmonics that rise up to the signal level. And then we're going to look at the power output. This radio, I don't have the documentation for this thing, and I can't exactly find it. I believe it's about 1 to 2 watts, maybe 3. So we'll see what we get. I'm going to look at it on here, and then we're going to hook it up to the oscilloscope, and we'll also look at it on the oscilloscope. Perfect. So that takes us up to minus 34 dBm. This RF tap is 30 dBm of attenuation, so we're getting about minus 4 for an output signal on the spectrum analyzer. And keeping in mind that this is an RF tap, an inductive RF tap. So this is telling me around 1 watt, maybe 2. However, as I said, the signal looks fairly clean on CW. I'm not showing you FM or sideband. That's a little more complicated to set up, but this shows us what we want as far as the relative purity of the signal. All right, let me break this down and let's set up the oscilloscope and take a look at the signal on that. All right, I've got our test set up, rigged up here, and what I've got is we're coming out of the radio on a BNC cable going to our scope probe. This is a 10x scope probe, and I have my impedance set on the scope to 1 megohm, so we can do this without smoking anything important. There's other ways to do this with the right kind of tap. I don't have that tap, so I couldn't really get a good power reading, I believe, with the taps I have. So this way should work, and hopefully none of the magic smoke will come out of this. So what I'm going to do is I've got this in CW mode, and I'm on 20 meters, and I'm just going to key, and we're going to take a look down here at the bottom what our peak-to-peak and our RMS voltage is, and then from that we can derive what the output power of the radio is. And so that's showing about 50 volts peak to peak and 17.1 RMS on our signal, and that's at 20 meters. So I'm going to jump down to 40 meters and let's take a look at what that looks like. And so we have 49 point some change, and we're getting about 17 and some change RMS. So our output power is just about the same on those two bands. Let's go up in band and change to, let's go to 6 meters. All right, guys, here's 6 meters, and let's take a look at our power readings. And a little less power on 6 meters, about 9 volts peak to peak, and 2.4 RMS. So great. All right, I'm going to put a slide together to show the math on this, and we'll go from there.
Okay, so here's the math, and this is a simple slide, and I apologize, I'm not a slide maker, and I'm only an amateur radio operator, so you know, take this all with a grain of salt. The math is on the internet, and I will try and point you to some other resources if you're interested in the comment, or not in the comments, in the description below. But based on what I showed you on the oscilloscope, so our 20 and 40 meter output power was identical. It's the same thing. And so there's our formula. Power equals E squared over R. R is our output impedance, our resistance.
and E is our voltage. So our output power should be E squared over R. So on the 20 meter and the 40 meter bands, both same math, 17 squared over 50, which is 289 over 50, which equals 5.78 watts output power according to the oscilloscope. Now, I don't have a digital meter out here to hook it up. I was honestly too lazy to get my nice one out of the house and bring it out here to the shop, but I feel that it would probably be fairly close to that reading, and I trust the oscilloscope probably a whole lot more than I would trust the meter. On 6 meters, we saw a whole lot less power output, so we had 2.7 volts RMS on our output for 6 meters, and I believe that was about 9 or 10 volts peak to peak. I didn't put that on the slide. But what we're interested in is our RMS voltage. So 2.7 squared equals 7.29. 7.29 divided by 50 equals 1/10 of a watt output. So there is the math for what I showed you guys on the oscilloscope.
Guys, that's all I have for you today. Hit that thumbs up and subscribe if you're not subscribed, and make sure to ring the bell so you get notified whenever I post any new videos. And always, thanks for watching. 73, guys.